The dual digital shift register is an aleatoric sequence generator, which uses gate signals to create pseudo-random patterns. The word aleatory comes from the Latin word for dice and refers to things determined by chance. The term is most often associated with procedures in which the chance element involves a relatively limited number of possibilities. The DDSR has 2 channels, both of which have 2 gate inputs, clock and data, and 5 outputs, 4 gate outputs arranged vertically and indicated by the blue LEDs, and a CV output. The state of the 4 gates determines the CV output. There are quirks and personality to the dual digital shift register. It is not precise, it is not perfect. It is fun, and there are a wide variety of applications, though. Let's start patching. Start by patching a gate signal into the clock, then patch a gate signal into the data. When the module gets a clock signal, it looks at the data input. If it's high, it moves a high signal into the first stage of the shift register, Q0. If it's low, it moves a low signal into Q0. This also causes the data already in the shift register to move by one stage, Q0 to Q1, Q1 to Q2, and so on. When the data reaches Q3, it is XORed with the incoming data. That means the data input will be high if one or the other signal is high, but low if both or neither are high. The 4 stages are summed together using a digital to analog converter and output as CV. The width of the clock signal doesn't matter, as the module only looks for new data during the rising edge of the clock pulse. The data needs to already have been high when the clock goes high for the shift register to recognize it as a high signal. The internal gates can also be used as a good source of data for the opposite channel. This also creates 2 separate but interrelated sequences. The range of the CV is not the normal 0 to 5 volts of Eurorack. It's about 0 to 4 on the right side and 0 to 3 on the left. It is intended for subtle modulation. Let's hear it used to sequence the pitch of an oscillator. Here we're listening to channel A, the left side. And here's channel B. And back to channel A. Changing the rate of the data signal will affect the resulting sequence. Pitch sequencing is not the only way to use randomness in modular synthesis. Here we use the channels of the DDSR to help animate a simple 16-step sequence. And some different combinations of clocks. This has been a basic overview of the dual digital shift register. In the next video, we'll go over using the gate signals as timing and modulation sources.